Good morning. Today we are going to discuss genetic algorithm from Unit 5 of Machine Learning. So, genetic algorithm actually belongs to the class of evolutionary algorithm, and it is adaptive heuristic search algorithm. Also, it is based on the genetics and natural selection. Basically, it is based on Charles Darwin theory of natural selection, that is the survival of the fittest. Okay, so here it is used to generate high quality solution for the various optimization problem and the search problem. So it has become very popular nowadays, and it is actually adaptive heuristic search algorithm. Adaptive is actually, it is adaptive with the environment, that is in terms of the number of parameters or the type of the parameters. Now, genetic algorithm, the first thing we have is the population. So here it actually represent each of the solution as the individuals that belong to the population. Okay, so here the solution or the individuals is represented as point in the search space. So here the motive is to find the best possible set of solutions for the given problem. So that set of solution is represented by the population. So here each generation consists of population of individual, and each individual represents a point in the search space. Now how this solution or individual is actually represented in the search space? So here we need to perform some encoding on the solution so that we can represent it as a string of bits, that is actually analogous to chromosome structure. Okay, so genetic algorithm generates successor hypothesis by performing some of the operators that we will see, the crossover and the mutation operation. Okay, so we are given with the current population, which comprises the set of best possible solutions according to the current scenario. With each iteration we need to generate the next generation population. Okay, and we are going to optimize this population with each iteration. Now, what are the factors that motivated the use of genetic algorithms? So here it is known evolution based approaches are known to be successful and robust method for adaptation within the biological systems. And secondly, GAs can search spaces of hypotheses containing complex interacting parts. Okay, so it can include the complex features also. Okay, very easily in comparison to other algorithms. And third, genetic algorithms can easily be parallelized, so we can take advantage of it in order to decrease the cost of some computer hardwares. So what are its application? It is various, it is actually applicable in various optimization problems, and it can be used in various continuous systems like efficient designing of airfoil in aerospace engineering. It can be used in multi-objective optimization problems as well as managing financial market. Now, as we will go through the procedure of genetic algorithm, we will find that it takes longer time to find near optimal solutions. Okay, and it is actually sensitive to the input parameters. Now, what is the typical structure of genetic algorithm? So here the problem addressed by genetic algorithm is to search a space of candidate hypothesis to identify the best hypothesis. That I have discussed that the main motive is to search a population which consists of the best solution, that are the hypothesis. Okay, for a particular problem. Now in GAs, the best hypothesis is defined as the one that optimizes the hypothesis fitness. Okay, so we have, how we will know that this hypothesis is the best? For this we have a measure known as the fitness function. Okay, so on the basis of that we will decide which of the hypotheses is are better than the other. So that fitness measure basically indicates the accuracy. Okay, now the algorithm operates by iteratively updating the pool of hypotheses. So with each iteration we need to update the population, which includes the set of best hypotheses, until the desired criteria is met. Okay, until we get the desired value for fitness function. Now on each iteration all members of population are evaluated according to the fitness function. On the basis of then fitness function we will select the members, or we will select the hypothesis which could be used for generating the next population solution, or which can be included in the next population. Now a new population is then generated by probabilistically selecting the most fit individuals, and once the most fit individuals are selected from the current population, then we will apply the operators like crossover and mutation, and then we can get the best possible solutions or hypothesis for the new population. Okay, so how you will select the most fit hypothesis? That is done with this probability, which is just the ratio of the if the of the hypothesis hi which you want to include in your new population, and the summation of the total fitness value of all the solutions present in the population. Now here some of these selected individuals are carried forward in next generation population as it is. That is, we don't want to lose the best solution we had in the previous generation. So some of the solutions are carried forward as it is, while we are going to replace the other solutions. Okay, so with each iteration a new population is generated, and this population basically comprises some of the new offspring that is generated. Okay, and some of the individuals from the previous population. Okay, now let us see the main step of genetic algorithm with the help of this flow diagram. So the first step is the initialization. So in initialization we will initialize the population with the set of all possible hypotheses which are best according to the given problem. So then we will perform some encoding so that we can represent those hypotheses in the form of bit string. Okay, now the second step is fitness assignment or fitness evaluation. Now on the basis of fitness function, that can be accuracy, we can find the fitness value for each of the hypotheses in the current population. Now based on the fitness value we will select the best hypothesis out of current population, and we will perform crossover operation and mutation operation, and so as to generate the offspring or solution for the next generation. Okay, or new population. Okay, so here what we will do, we will perform the crossover and the mutation operation to generate the offsprings. Okay, so these are the most common operators. So crossover operator produces two new offspring from two parent bit strings by copying selected bits from each of the parents. Here we have crossover mask also for this, that we will discuss in next lecture. And mutation operator basically produces small random change to the bit string just by choosing one of the bit at random and inverting its value. Like if its current value is 1, then we will set its next value as 0. Okay, so this is just to maintain some diversity in the new population. Now again we will check, after we get the new population, we will check the fitness function value for the new population. Okay, or all the hypotheses which are in the new populations are check again the fitness value. Now if the desired criteria is not met, again we will repeat this procedure. Okay, we will repeat this procedure. And when the what is the convergence criteria, it depends on the your problem statement. It can be number of the steps or the fitness value that you want. It actually depends on the, sometimes if it is time consuming, then we can reduce the number of iterations also. So it depends on the problem. So until the convergence criteria is met, this procedure is repeated again. We will find the fitness function for the new population. Again we will select some of the members from the population, we will apply crossover and mutation, and we will include the offspring in the new population. And while we will copy some of the individuals from the current population also in the new population, so that we can get best possible solution each time. Okay, so this is the flow diagram for the genetic algorithm. Next we will discuss the genetic algorithm in prototypical model. Okay, so that's all for today. Thank you.